report the chaos. We reveal the agenda.
On November 23, 2025, the Hayli Gubbi volcano in Ethiopia's remote Danakil Depression erupted, breaking 12,000 years of dormancy. This explosive event shattered the geological quiet of the northeastern Ethiopian rift zone, part of the Afar Triple Junction. Here, the African, Arabian, and Somali plates diverge at a rate of 1 to 2 centimeters per year, creating extreme landscapes. The Danakil Depression is one of Earth's hottest inhabited places, with average annual temperatures exceeding 34 degrees Celsius. Ground temperatures can reach up to 70 degrees Celsius, featuring colorful hydrothermal fields at Dalal and vast salt pans. The eruption produced a high-altitude volcanic column, piercing the tropopause at 45,000 to 50,000 feet. It released approximately 220,000 metric tons of sulfur dioxide and fine volcanic glass shards. This plume was immediately captured by the subtropical jet stream, with winds of 50 to 100 knots. The plume traveled eastward across the Red Sea within hours, blanketing Yemen and Oman on day 1 and 2. It then drifted over the Arabian Sea to western and northern India within 3 to 5 days, with potential dispersal to South Asia. The timing amplified global impacts, occurring just 2 days after the Dubai Airshow 2025 concluded. This disrupted the post-event dispersal of international aviation fleets from Dubai, one of the world's busiest airports. While no flight cancellations from Ash were detailed, heightened alerts affected Middle East-Asia routes. Locally, there were no direct human casualties from the blast, but profound threats emerged for the indigenous Afar people. Approximately 500,000 Afar rely on pastoralism and the regional salt trade, which supplies 20 to 30% of Ethiopia's salt. Lava flows and tephra fallout contaminated water sources, risking livestock die-offs and famine. Humanitarian aid was mobilized by the Ethiopian Red Cross and the UN to address these critical needs. Globally, the SO2 injection could cause 0.1 to 0.5 degrees Celsius regional cooling for 1 to 2 years via stratospheric aerosols. Aviation hazards extended across a 5,000-plus kilometer path, impacting flight safety and operations. Potential acid rain in India could affect agriculture, particularly the rice and wheat belts. Health risks from respiratory issues also emerged in Yemen and Oman, exacerbating existing crises. The 2025 Hayli Gubbi Eruption serves as a stark reminder of Earth's dynamic geological forces and their far-reaching consequences. Understanding these events is crucial for global preparedness and mitigating future impacts on human systems. To understand the violence of the 2025 eruption, one must first understand the unique tectonic architecture of the Afar Depression. This is not a landscape of random accidents, but a highly structured machine of continental breakup. The Afar Depression is the surface expression of a tectonic triple junction, a point where 3 tectonic plates are pulling away from one another. This divergence creates a thinning of the Earth's crust. In most parts of the world, the crust is 30 to 40 kilometers thick. In the Afar, it can be as thin as 20 kilometers, and in some active rift zones, it is barely there at all, replaced by magmatic intrusions. This thinning allows the underlying mantle, the hot viscous layer beneath the crust, to rise closer to the surface. This process, known as decompression melting, generates vast quantities of magma. Hayli Gubbi lies at the southern end of the Erupted volcanic range, a segment of the rift that behaves much like a mid-ocean ridge exposed on land. While the northern part of this range is dominated by the Erupted volcano, famous for its persistent open-vent lava lake, Hayli Gubbi has historically behaved differently. It is a shield volcano, characterized by broad, gentle slopes formed by fluid basaltic lava flows in the deep past. The Smithsonian Institution's Global Volcanism Program had classified Hayli Gubbi as having no known eruptions during the Holocene. The Holocene epoch covers the last 11,700 years, essentially the entirety of human civilization since the last ice age. For a volcano in such a hyperactive region to remain silent for so long suggests a specific set of underground conditions. Dormancy in a volcanic system is often a period of pressure accumulation and chemical change. Over millennia, the magma in the upper conduits cools and solidifies, forming a rock plug that seals the volcano. This seal prevents the continuous leaking of gas seen at nearby Erta Ale. While the volcano sleeps, the magma chamber deep underground does not. It undergoes fractional crystallization. Heavier minerals settle out, leaving the remaining liquid magma richer in silica and dissolved gases. This process can convert runny basaltic magma into sticky explosive types like trachyte or rhyolite. The 2025 eruption was likely triggered by a recharge event. Fresh, hot basaltic magma from the mantle injected itself into the stagnant, evolved chamber. This injection added heat and volume, increasing pressure. Crucially, the mixing of hot and cool magmas triggered massive volatile exsolution, the rapid release of dissolved gases. When the internal pressure finally exceeded the strength of the 12,000-year-old rock plug, the system failed catastrophically. The bomb-like explosion reported by residents was the physical shattering of the seal, driven by expanding gas. The eruption did not occur in a vacuum. The Afar region has been seismically restless for decades. Retrospective analysis of seismic data indicates a period of heightened activity in the Afar and Oromia regions leading up to late 2025. January 2025, significant earthquake swarms were recorded near the Fentale and Dauphin volcanoes to the south. These earthquakes are symptoms of the rifting process. As the plates pull apart, the crust cracks, and magma moves into these cracks. The connection. While Fentale is distant, the stress transfer along the rift axis acts like a zipper. Tension released in one segment can increase strain in another. It is highly probable that deep magmatic movements associated with this regional unrest eventually breach the reservoir beneath Hayli Gubbi. Shield volcanoes typically produce lava flows. The production of a 50,000-foot ash column is highly anomalous for a standard shield volcano eruption. This points to bimodal volcanism. This suggests that the magma involved in the initial phase was highly evolved, or that the ascending magma encountered a significant body of groundwater, leading to a phreatomagmatic eruption. However, the height and persistence of the plume favor the theory of a gas-rich, evolved magma cap being blasted out by rising basalt. The pinkish hue of the ash clouds observed in satellite data further supports the presence of rhyolitic or trachytic material, which is lighter in color than black basalt. The physical manifestation of these geological forces occurred on a Sunday morning, transforming the routine of the local Afar population into a fight for survival. A massive explosion occurs at Hayli Gubbi. Residents report a sound like a bomb and a shockwave. The ash column ascends rapidly, piercing the troposphere. VAAC Toulouse detects the anomaly. Satellite data confirms the plume top has reached 45 to 50,000 feet. The plume shears. High-altitude finds move east-northeast. Heavy tephra falls northwest near Afdera. Eruptive intensity decreases significantly. Re-explosive phase is considered over. Eyewitness accounts from the nearby village of Afdera describe a scene of apocalyptic suddenness. Unlike the low rumble of a lava flow, this was a sharp, concussive blast. Ahmed Abdallah, a resident, stated it felt like a sudden bomb had been thrown with smoke and ash. The eruption column was white and gray, dense with water vapor and pulverized rock. As it spread, it blocked out the sun, plunging the village into midday darkness. Ash fell heavily, coating the white salt pans of the Danakil in a layer of gray dust. This volcanic snow was composed of jagged glass shards, devastating to breathe and lethal to machinery. The eruption was invisible to most of the world until satellites passed overhead. NASA Worldview, MODIS, captured the thick plume contrasting sharply against the arid desert and the blue of the Red Sea. Sentinel-5P Tropomi detected the massive sulfur dioxide signature. The total mass was estimated at 220,000 tons. This is a significant injection, though an order of magnitude smaller than climate-altering eruptions like Pinatubo. Meteosat-10 used RGB composite imagery to distinguish between the ash and the gas. The imagery showed a clear separation, a pinkish ash cloud moving northwest and a green SO2 ash mix moving east. Once ejected, the volcanic material became a passenger of the global atmospheric circulation. The eruption column's height, 15 kilometers, placed it squarely in the upper troposphere and lower stratosphere. Here, the subtropical jet stream acts as a high-speed conveyor belt moving west to east. The trajectory of the cloud was swift and relentless, beginning its transcontinental drift. Within hours, the plume traversed the narrow Red Sea, separating Africa from the Arabian Peninsula. By November 24, the cloud was over Yemen and Oman, prompting the Oman Environment Authority to issue warnings regarding air quality. The cloud continued its journey over the open Arabian Sea, broadening and thinning as it moved eastward. On the evening of November 24th, the cloud entered Indian airspace over Gujarat. By November 25th, it had spread over Rajasthan, Punjab, Haryana, and the National Capital Region, including Delhi. The arrival of the cloud in India did not result in heavy ashfall on the ground. The particles were too fine and too high, over 25,000 feet, to settle quickly. Instead, it manifested as distinct optical and atmospheric phenomena. Residents in Delhi and northwest India reported skies that appeared darker and hazier than usual. The scattering of sunlight by stratospheric sulfur aerosols created unusual pinkish, orange, and unusually muted dawn colors on November 25th. While the ash remained high, there was significant anxiety that it would mix with Delhi's notorious winter smog. The India Meteorological Department clarified that the plume was passing over the surface pollution, not mixing with it. However, trace amounts of sulfur dioxide were detected at high altitudes, indicating the subtle yet far-reaching impact of the eruption. The intersection of a stratospheric ash cloud and one of the world's busiest air corridors resulted in immediate and costly disruption. Volcanic ash is a supreme hazard to jet aircraft. The melting point of the silica glass is lower than the operating temperature of modern jet turbines. Ingestion of ash causes the glass to melt and then re-solidify on the turbine blades, leading to compressor stall and engine failure. The eruption occurred on Sunday, November 23rd, shortly after the Dubai Airshow 2025, which ran from November 17th to 21st. While the show had concluded, the region was still heavily trafficked with returning delegations, display aircraft, and business executives, leading to congested airspace. The airshow had celebrated the pinnacle of aerospace technology, securing $202 billion in deals. Yet, 2 days later, primitive geology grounded that same technology. The aviation mood in the region was already somber due to a tragedy during the airshow. On November 21st, an Indian Air Force HAL Tejas fighter jet crashed during an aerobatic display, killing the pilot, Wing Commander Namanj Sile. This unrelated event had already put safety protocols on high alert, compounding the logistical nightmare for Indian aviation authorities. As the ash cloud drifted over the Arabian Sea, a critical corridor for flights between Europe, the Middle East, and Southeast Asia, air traffic control centers were forced to close airspace sectors. Notable disruptions included Indigo Flight 6E1433 from Kannur to Abu Dhabi, which was diverted due to ash in the Muscat Flight Information Region. Indigo Flight 6E1475 from Cochin to Dubai was cancelled as a safety precaution. Air India flights AI-106 from Newark to Delhi and AI-102 from New York to Delhi were cancelled because the route was unsafe. Air India flight AI-2204 from Dubai to Hyderabad was cancelled due to ash in the departure zone. Akasa Air cancelled all flights to and from Jeddah, Kuwait, and Abu Dhabi under a blanket safety ban. KLM flight KL871 from Amsterdam to Delhi was cancelled due to ash in the approach path. Mumbai ATC reported 28 flights had to be rerouted to avoid the ash polygon in the Muscat Flight Information Region. This added flight time, fuel costs, and operational chaos. India's Directorate General of Civil Aviation issued a strict advisory mandating that any aircraft encountering ash must report engine performance anomalies immediately. Airports were also ordered to inspect runways for ash deposits, which can reduce braking action. The combined impact of the volcanic ash crisis and the Tejas crash underscored the need for enhanced safety measures, communication, and international cooperation in aviation. On November 23, 2025, the long-dormant Hayli Gubbi volcano, inactive for approximately 12,000 years, in Ethiopia's Afar region erupted violently, sending a massive ash plume high into the atmosphere and spreading across vast distances, disrupting international air travel. While the world focused intently on flight disruptions, with airlines canceling or rerouting flights over regions like Yemen, Oman, Saudi Arabia, Pakistan, and India, as reported by the Tulu Volcanic Ash Advisory Center. The Afar people in the Afdera Wareda faced a landscape completely destroyed by thick ashfall, a critical district for pastoralism and Ethiopian salt production. The Afar are semi-nomadic herders who rely heavily on goats, camels, and cattle for their livelihoods, traversing the already scarce vegetation of the harsh Danakil Depression in northeastern Ethiopia. The heavy ashfall has blanketed the grazing lands across many villages, leaving animals with little to eat, as confirmed by reports, thereby creating a severe famine risk for both livestock and the dependent herders. When livestock ingest ash-covered grass, the sharp, abrasive glass particles in the volcanic ash wear down their teeth progressively and lead to fatal gastrointestinal blockages known as bezoars. Essential open water sources in the arid desert, already scarce, were heavily contaminated by the ash, transforming into thick, undrinkable sludge that poses a dire threat to thirsty livestock like camels. The total destruction of their resource base has forced many Afar communities, including women and children, to displace urgently, seeking out new viable areas for survival amid the ash-laden terrain. In response, the government mobilized medical teams to a remote medical tent, treating residents for respiratory distress, such as persistent coughing and throat irritation caused by inhaling the fine silica dust from the ash. The eruption also gravely threatened the salt extraction industry, centered around Lake Afdera, a vital economic pillar for Ethiopia, as a visible layer of volcanic ash began settling on the vast, pristine white salt flats. This ash contamination directly jeopardizes the purity of the salt crystals being harvested, potentially halting an industry that supplies much of Ethiopia's salt and supporting countless local livelihoods. The Danakil Depression, known as a niche extreme tourism destination for its unique volcanic landscapes, saw tourists and guides stranded and disoriented as visibility plummeted to zero within the thick ash cloud. A powerful bomb-like shockwave from the eruption triggered widespread panic in the region, where poor communication infrastructure left those in its path particularly vulnerable and isolated during the crisis. In the short term, the volcanic ash is intensely destructive, being acidic from SO2 adsorption and physically suffocating plants under its heavy, smothering layers, leading to widespread wilting and damage. However, in the long term, over decades or centuries, the volcanic ash breaks down into highly fertile soil, rich in essential minerals such as iron, magnesium, and potassium, fostering new growth. Yet, for the current generation of Afar herders facing starvation, displacement, and loss, this geological gift represents a profound curse, delivering immediate devastation while benefits accrue only to future generations. The Hayli Gubbi eruption powerfully highlights the extreme vulnerability of the Afar region and the urgent critical need for enhanced monitoring, seismic networks, and disaster preparedness in remote volcanic areas like the Danakil.